Okay, does it help with the light on or off? What do you guys think? Light on or off? Okay. All right, so today is review day. From the quiz today, I think you will realize that writing questions is a lot harder than you thought, huh? Okay. But the one thing I will say about today's quiz is you kind of do have to take things from context. Even if I wrote the questions, especially on question number 4 that we did, that was a really good one. You have to decide from the context, is this about the sample or is it about the population? That's going to be a really key question. So that tells you whether to look at the Z table or whether the T table. So that's such a huge thing, and it's going to stay huge. So you've got to remember this not only for this test, but for next test as well.
It's going to be that huge, which it is. Give us some more tips on how to tell.
Can you give us examples of how to assume that sort of wording?
Tell you what, here's what I'll do. Here's some questions out of this book that are very similar. Let me see if I can. Chapter 8 here in ours. So do you want me to just pull up a one and then you can tell me what you think it is? Okay, do you want to solve it too, or do you just want to say how do I choose Z or T? Okay.
Is your test going to have student questions?
Yeah. Oh, and by the way, I'm glad you asked that question because let me just share this with you, because I don't think anybody ever, and I've actually been posting these more often. If you go here to the assignments and you go down to the bottom, oh, you can't see. Let me turn that on. Okay, the video can see. But if you go down here to the bottom, we've got here on the very book bottom, it says student generated questions, hurry up. I wish that you could just change the video instead of, oh, it's so slow warming up. Okay. All right, down the second one from the bottom here, it says student generated questions. How many of you have ever looked at this before? Really?
Yeah.
Okay. So here's we've got them all here. The normal uniform questions, the central limit theorem, proportions, and mean. In fact, do you want to do one of these student questions or one out of my book? One out of the book?
These are going to be on the test, and let's do these ones.
Yeah, we could. Now, the problem is, remember, you guys wrote them, so that doesn't mean the answer is correct.
I just feel like you can't post them for a test and have us study them. If, like, what if we do get it right, but then the answer is wrong?
Well, because you wrote them.
Well, yeah, but I just feel like that's not really.
Well, we can do that. Let's just pick one or two.
I feel like you should be writing them,
Okay.
checking them to make sure before we send them for a test.
Okay. How about this one? This is a good one here. If you do know the standard deviation, which distribution should you use? H, T, L, or Z? What is the H and the L? Never heard of those. I hope nobody ever picks those. So yeah, so the correct answer here, number 1, which distribution should you know? Actually, it says, do you know the standard deviation?
You need to know the population.
Okay, so that's a poor question. Okay, so for whoever did this, you need to say you need to specify population in here. Okay, so part of the thing is, this is good because you guys are not making a distinction here that you need to make. So here, I will fix this, and we'll upload it after class. Okay. Do you know the population? What's the answer if you know the population standard deviation? It should be Z, which is answer D, and that's the answer they put. Okay? If you do not know the population standard deviation, which one should you use? The T, which is answer B, and that's what they picked. Okay? Yes?
Maybe it'll be different on the test, but my way of thinking, like when I saw like that question clearly, knowing it's chapter 16, it says you got the standard deviation, I just assumed it was the population, so I assumed that's what it was. And is that wrong to do? Like knowing it's chapter 16, but maybe on the test,
On the test, you're not going to know which chapter
so
it's from.
you shouldn't. So it should say population.
It should say population.
So it'll most likely start
Okay?
somewhere.
It should, yeah, I'm fixing this, okay?
I just assumed that's what it was, because that's what we're talking about.
Right.
In the test.
But you need to be more specific, okay? How about this way? A survey of 600 people found that they sleep on average of 10.5 hours per night. So if the margin of error is 98% confidence level, that's really poorly worded, but anyway, is 1.3 hours. What is, I think that's what they're trying to say, the confidence interval. Okay, so here, let's figure this one out. Do you want me to figure this one out? Because this is kind of confusing. Okay, so your n equals 600. That's what I'm going to pull out first. What is 10.5? X bar equals 10.5. The margin of error, here we're going to reword this. This is what it should say. At a 98% confidence level, the margin of error is 1.3 hours, period. What is the confidence interval? I still don't understand why people leave. Those of you who had left that are maybe watching this at home, why do you come to school? Seriously, why? This is like the most important time to be here and you've walked out. Makes no sense to me. Okay? Not for you guys. That's for the people that walked out that may watch this video, but probably not, because they don't really care about whether they pass this class or not. Okay? Anyway, sorry for a downer there, but if you're paying good money, why not come to class? Get your money's worth. All right. So how would you find the confidence interval? This is now a good question. I will clean up questions. Okay? But this is good place to find them. Okay? How do you find this out? This should be an easy question now. Shouldn't it?
You take the mean x bar 10.5 and you add or subtract.
Plus or minus what?
1.3.
1.3. Okay. So that's going to equal, in this case, so if I subtract 1.3, that now becomes 9.2. And if I add 1.3, that becomes 11.8. Now, let's see what they got. Number 3, they put define student t-distribution. Okay. This is what the answer should be. Oh, is that right? Am I looking in the wrong place? Oh, yeah. Oh, actually, okay. Yeah, it is correct. Okay, good. Okay, so they got the right answer on that one. Okay. Not a bad, in fact, now that it's a little bit more clear, that's not a bad question. Okay. So yeah. Do you want me to pull some from a book, and then you're gonna tell me what you're supposed to do? Okay. I'm gonna pull some from a book. Okay. So this one is. A recent Gallup poll asked 1,006 Americans, when you read a book, do you finish all the way through? Results found X bar equals 13.4 and S equals 16.6. Construct a 99% confidence interval. Interpret. Okay, really good question. Now, before we answer the question, I'll take your question. What'd you say? S was 16.6. Okay? How's that? Okay? So, what's the first question you should ask yourself before you do any calculations? Z or a T, right? Do I know the population, or better question, do I know the population standard deviation? No. So therefore what? Therefore use T. Okay? So the formula for the T is X bar plus or minus T sub alpha over 2 times S divided by the square root of N. That's your formula. It's on your formula sheet. Okay? Hopefully you guys do enough of these that you're going to memorize those formulas, but you're going to be so familiar with them that they'll be almost memorized. But you can look at the sheet just to be sure. Okay, so how do I do this one? Let's pick on Aaron. Must be your turn. For the Z bar? So the X bar in this case is, in fact, if you're doing, we're going to do this with the computer because you guys wanted me to verify, to do this on the computer, right? Okay, so in order to do this on the computer, now it's a good idea, X bar, just go through here. This one's pretty specific. I'll try if I can find one a little bit more vague. And S equals 16.6. I need my T sub alpha over 2. And in order to find my T sub alpha over 2, what else do I need to know? I need to know my N. I need to know my degrees of freedom. It's a 99% confidence interval. What do you know there? We know our N, right? N is 1006. Degrees of freedom, 1005. Then what? Your 99% confidence interval, so yeah. So which column are you looking at? Now, by the way, did I tell you what the command is for, okay, here, we're going to do it two ways. We're going to do it with the table, and we're going to do it with the computer. Okay? Inverse something, that's correct. We'll do that in just a second. So with the table, let's make sure we know what it is with the table. So here I've got my table here, okay? How would you use your table in this case? My N was 1005. Unfortunately, I don't have 1005 on my chart, do I? I have 1000, so you're going to go the closest. I think on today's quiz we had 800 on there, right? 800 is not on the chart. What should you use? 1000 because it's closer. Okay? All right, so we're at 1000. I know that's super small. Okay? Which column am I looking at? For a 99% confidence interval, I'm going to ask Gabrielle to make sure we got this good. Which column am I looking at? Uh-huh. Oh, I wanted you to succeed. We answered. Which column? 0.005. So I'm looking at this column here. What's the value? It's 2.581. Do you see that? So with the cable, I get 2.581. Okay? Now with the computer, how could I do that? Equals T dot inverse. Two tails. How much do I want in my two tails? Well, in both my tails, I want 0.01, right? I'm going to use my whole alpha this time. This is going to be 0.01, and my degrees of freedom in this case is 1005. So this is going to be more accurate because I got better degrees of freedom, but it's going to be very close to 2.581, 2.58073. Okay? Very close. Which formula? This one?
It's on our sheet, right?
That's on your sheet, yeah. Right here. Two, oh, actually, I don't have T dot inverse dot two tails. I got inverse and right tail, but two tails also better. Go ahead. Just remember that one, okay? It's just out two T.
And then in the parentheses.
Remember, when you're typing these in, okay, watch this. If I type T dot inverse, oh, it doesn't have a right tail on there. It's got two T. Okay? I put RT, but it's actually two T. Okay? So if you start typing, it will tell you what the command is. Okay? Does that make sense, John?
So the first part is the percent.
Did you ask that question? Oh, that was Ben. Sorry. Okay. Does that make sense? Okay. 0.01 and 1,005. Okay. Yes. Was there another question? Okay. The point from the 99% confidence interval to the alpha is 1%. Okay. So just as a reminder, let's draw a picture here. Okay, if I'm drawing this here, okay, we know by the central limit theorem that this is normally distributed, right? Okay, my x bar was 13.4. Yeah, x bar was 13.4. If I go out here 99%, that's my 99% confidence interval. We haven't figured out what those values are yet. We're going to figure out what these values are in a minute. But that means I've got a 0.005 here. That's your alpha over 2. 0.005 here. That's also your alpha over 2. You combine them together, your alpha is combined 1%. 99 minus 1, or plus 1 is 100%, right? Okay? So that's where we're getting that from. So I don't know, that might help you to draw pictures. And then you can distinguish between your alpha and your alpha over 2. Okay? Does that help, Gabrielle?
Yeah.
I want you to get this down today. You got to ace the test Tuesday, okay? Oh, by the way, let's speak about the test. The written test is going to be Tuesday. The computer test, I had to schedule it for Wednesday through Friday. Okay? So I will have your results back for the written test on Thursday. Obviously, I won't have the computer, but I'll do that over the weekend. Okay?
So what's going to be expected on the computer exam? Just like what you're doing.
Yeah, so let's finish this example here. Okay? Now, if you're doing, oh, I do not want to stop recording. I want to share. Okay? So if you're doing this problem and it's on the computer, okay, a 99% confidence interval, I'm going to do a lower, and I'm going to do an upper, okay? And I'm going to use the computer values because I'm on the computer, okay? If I'm on the paper, I'll use the paper test. With the table, I'll use those values, okay? All right, so in this case, Elizabeth, tell me what to do. Tell me what to type. We're finding the confidence interval with this equation right here that I wrote out.
Just plugging in numbers?
Yeah.
So 13.4.
13.4 minus 7.3 times 16.6. Boy, that's a big standard deviation. In fact, isn't it amazing that the standard deviation is greater than the mean? That's really bizarre. Okay, that's like a huge standard deviation. Okay, divided by the square root of 1,006. Okay. Can I copy and paste that?
Yes.
Oh, it didn't work. How come it didn't work? Because I copied it wrong. Okay. Copy up here in the formula bar. If you highlight the formula, if you press Control C, now when you press Control V to paste, it actually gets the exact same value. What's the only change I make to this formula? Change that minus to a plus. Booyah. Okay. Now I would love to have, I'm going to pick on, is it Sarah? Oh, it is. Sarah, can you give me a confidence statement? How confident are you in doing that?
We are 99% Americans who read the book all the way through the mean is between 14.75 and 12.
Okay, so you said the upper first. Always do it to the lower than the upper. Between 12.05, comma 14.75 books. Okay? Not the most elegant wording, but it's okay. I'll give it to you. Okay? Does that make sense? Are you going to ace my test? Yes, John.
Just a question, when we write that out, do we have to put the numbers in parentheses since you did?
That's usually how you do it, is you put it in parentheses, yeah. Okay? All right, let's do another one. How about this one? I'm going to make it my own, sort of, based on something else. Okay. No, you're going to do this. Okay, let's say, I'm just going to make one up. Okay. Let's say that the mean cost of groceries in Salt Lake City is $103.15, and standard deviation is 5.75, 74. I don't care. That's fine. Okay. You want to know if the price is different in Provo, and do a sample of 35 grocery stores and find the mean is 92.73 with standard deviation of 6.63. Fine. So here, I'm going to do a couple questions here. We're going to do a find. First of all, find the 95% confidence interval for Provo. B, interpret. And C, is the cost of groceries significantly lower in Provo? Okay, hope these are good numbers. We're going to find out. That's what happens when you make up a problem in your head. It might be terrible. Okay, so what's the first question you should ask yourself? Do I know the population standard deviation? Yes. Okay. So it's going to be a Z. Does anybody disagree with me? No, because what are we assuming the population is? What? That's a better question. What is the population? Yeah, it's the price of groceries in Salt Lake City. Okay? So we're trying to compare our sample, because apparently we read this somewhere. It must be right. Okay? Okay? All right. So now, how do you find the 95% confidence interval for Provo? What's the equation you use? Is that yours or my copy? You printed it off, it's your copy? Okay, go. So, just making sure you didn't steal mine.
Put it there for me to steal, so I did.
So, what? So it's going to be x bar plus or minus. Alex, can you finish off this formula? No? Melina will let you finish it off, but Alex is going to do the problem because we want to make sure Alex passes the test.
1.96.
Well, okay, just the generic formula.
Oh.
Z sub alpha over 2 times sigma, not standard deviation, sigma square root of n. Okay, so Alex, you've got that thing now. Let's figure out, do we know what x bar is? Actually, let's go through every number in here. Let's properly label them. Something is 103.15, Alex. What is it? No. It's mu. Why is it mu and not x bar? Because Salt Lake City is the population, right? Okay, what is 5.74? Alex? Which standard deviation? Sigma. Okay, then I got 35 grocery stores. What's 35? I'm asking for a letter, either Greek or American. N, okay. What's 92.73? X bar. Well, thanks to the phone a friend thing, okay. And the 6.63 is? Which one? Sure? Okay, good. S. It's S, okay? Now, here's the deal, okay? If this is still confusing to you, you're gonna do terrible on the test. Really, this should be common nature, you know? You should go through this and you should just know this. If you don't know it, you haven't practiced enough, okay? All right, so now we're gonna use this. Alex, I want you to help me out. Lower, upper. So we're going through this formula. Tell me what to type. Equals. 2.73. Oh, there's one more thing we're missing. I just realized. We need to know our z sub alpha over 2, right? Everything else we've got. What's my z sub alpha over 2? Got to find that on the chart, right? We're out of time, so we got to hurry. Thanks, Elizabeth. What's the chart? Say 1.96. Okay. Okay. I'm going to let Hannah finish this off. Sorry. Equals, which is 2.73 minus, which is 1.96 times parenthesis 6.63 divided by square root of 35. Okay. Oh, why? Oh, actually, we made a mistake. We were supposed to use sigma, aren't we? We're not supposed to use B18. We're supposed to use 5.74. So Hannah needs to study more. Okay. Okay. Now, if we copy it up here and paste it, we should get the same number. We change that minus to a plus. Alex, you can interpret it. We are 95% confident that groceries in Provo are between $86.30 and $99.16. Okay, now the last question I'm going to pick on Sydney. Is the cost of groceries significantly lower in Provo?
Yes.
Yes, because why? The confidence interval does not contain 103. So yes, because the confidence interval does not contain 103.15.
So it wouldn't be significant.
Actually, you know what, we really should do, yeah, because 103.15, yeah. If 103 was in here, then it would not be significantly different.
Did you get that on tape?
I got that on tape.
Just in case you mark me wrong on my test.
All right, by the way, one last thing before you guys go. This is bonus time, I know this is. Because we mentioned something, but we didn't get it on tape, and I want to talk about this. Let's just say, for example, that I get a t-score, a t-value equal to 1.5, and my degrees of freedom equals 70. Find the p-value. Okay, how would you do that with the chart? Okay, so 1.5, I'm looking for 1.5 on this line. Where does 1.5 fit? Fits in between those two numbers, right? So therefore, your p-value is going to be between those two numbers. Sorry, 70, 1.5, it's between those two numbers. It's between those two numbers. So your p-value is going to be between 0.05 and 0.10. We're probably going to do that a lot more on the next test, but since it came up on this homework problem, I thought it would be good to show you guys a quick, okay? All right, so quiz on Tuesday, study hard. If you have questions, text me. Did you guys have my text? It's on the syllabus, okay? I will talk to you on the phone. Maybe I'll get a little video conference if you want. We'll make sure you understand this, okay? Just don't call me Friday night, I'm at the Jazz game. Or Tuesday night, I am too. Okay? See y'all.